We're in Unit 5 and we've been talking about finding solutions to polynomial equations. Now we're going to do a reverse here. Instead of us being given an equation and we need to actually find the solutions to the polynomial equations, we're going to reverse course. I'm going to provide you with solutions and we're going to come up with an equation that has these unique solutions. So we're going to do two examples that are easier. This one contains 3 solutions and this one contains 4 solutions. You will notice that the numbers I'm providing you in these two examples are integers. They don't have any rational components to them. They don't have any values with i's, and we'll learn more about that into the end of this unit and next unit. Let's start out with this first example. Please write down. We have 3 real solutions of -1, 3, and -4. Now, how do we come up with an equation? Well, we're going to write this right now in factored form. And when we put it in, I'm going to start, everyone is going to be x subtract. Now, in parentheses behind that subtraction sign, I'm going to write in the solutions that I'm provided. -1, +3, and -4. I know 2 negatives make a positive, so this becomes x plus 1. The second parenthesis, x subtract 3, and the third one is x plus 4. Now, I don't want you to stop right here. Remember, we're writing the equation, so I'm going to have y equals. I actually want us to be in standard form when we're done. Standard form will look like x cubed plus, example, 2x squared minus 3x plus 4, something like that. There's different ways we can do this. Ultimately, I'm going to put 2 of these together first. Now, here's how you may have learned to do it. You may have learned to do this using what's called the FOILing method. Multiply the fronts to get x squared, multiply the outsides to get -3x, the insides achieve +1x, and last, +1 times -3 is -3. When you combine like terms, which would be the 2 middle terms in this case, this is what I end up with. But notice, I still have a third parenthesis, a third factor that I need to contribute to achieve the equation of the polynomial equation that has these unique 3 solutions. So here's what I get when I combine the first 2. I multiply the first 2 parentheses, but now I need to take it times the third. Now I'm going to show you an alternative way to do this next. Okay, so I'm still doing the idea of FOILing, which is distributing, but I'm going to take this term times all 3. So if you want to make like upside down rainbows, this is what I'm going to do. X times x squared is x cubed. X times -2x is -2x squared. X times -3 is -3x. I'm going to do the same thing using a +4. So +4 times the first term is +4x squared. +4 times the next term is going to be -8x, and +4 times the last term is -12. Now my goal is to come up with an equation written in standard form that is a polynomial equation with these 3 unique solutions. So let's combine like terms. There's only one term that has an x cubed. There are 2 terms with an x squared. When I combine them, I end up with a +2x squared. -2 combines with +4. There are 2 terms with just a singular x, -3, and -8 is -11, and I'm going to drop down the -12. I'd like you to watch me achieve the same answer using a different method, because I believe this secondary method will be much to your benefit to use when we get to more complicated problems in this video. So here's what I'm going to do. I'm going to start by combining these first 2. Notice this has 2 terms. Okay, so it has 2 terms. I'm going to put, there's 2 terms. And this has 2 terms. So I'm going to have 2 terms. And then I'm going to make, in this case, a square. Now, it doesn't matter if the x plus 1 goes on top or if it goes on the side. It doesn't make a difference. So here's an x and here's a +1, and here's an x and here's a -3. And you may have learned how to combine by multiplying, doing this in 8th and 9th grade. So I'm going to multiply x times x is x squared, x times +1 is +1x, -3 times x is -3x, and -3 times 1 is -3. Now the cool part about this is when you combine this, I only have 1 term that has an x squared, but now the diagonals have like terms. -3 and +1 is -2x, and there's your -3. Okay, so this has 3 terms. 1, 2, 3. I'm going to multiply it by this lone parentheses or factor that only has 2 terms. So this has 3. So I can have the 3 go down the side or up top. I'm going to have it go up top. So there's an x squared, a negative 2x, and a negative 3. And then along the side, I'm going to have there's an x and there's a positive 4. Okay, time to multiply. X times x squared, x times negative 2x, x times negative 3. Now positive 4 times x squared, positive 4 times negative 2, positive 4 times negative 3. Okay, notice there's only one x squared, or x cubes, excuse me, but the diagonals, this is the nice part, the diagonals I combine to get a positive 2x squared. The diagonals combine to give me a negative 11x, and there I have a constant of negative 12. I got the same answer, it's just another method to produce the same answer. Let's look at example number 2. Now, example number 2 is also going to be on the less complicated end of this, especially when we look at example 3 and 4. So I'm going to start by writing this out. This is called factored form, and so I want to produce a polynomial equation that has 3 exact roots, exactly what I see. So I'm going to go with x minus, x minus, x minus, and x minus. And now in these positions, I'm going to put in a 2, a 0, a negative 1, and a 3. This becomes x subtract 2, and x subtract 0, that's really just x, but if you want to write x subtract 0, you can. 2 negatives make a positive, again, and x subtract 3. Okay, so I'm going to use the secondary method because I know it's going to be helpful when we get into future examples. Notice this has 2 terms in it, so I'm going to do 2 terms here. X minus 2, oh, sorry, what did I do there? X minus 2. And I can choose any one of these. So remember that when you take 2 times 3 times 4, whether you take 2 times 3 to get 6, and then 6 times 4 gives you 24, or you could take 2 times 4 is 8, and then 8 times 3 is 24. So the order you multiply doesn't matter. The same thing here. I have x subtract 2, so I'm taking this first parenthesis, and I could take the third parenthesis. X plus 1. So these are the 2 that I'm going to combine right now. I end up with x squared minus 2x plus 1x minus 2. When I combine, I have x squared minus 1x minus 2. So I have taken care of these 2 parentheses. Now I'm going to multiply by this third parenthesis. I'm saving this one for the last because I think it's going to be the easiest to distribute by. Okay, so this has 3 terms. So let me make a box with 3 terms. There's an x squared, a minus 1x for a term, and a negative 2. And then I have an x and a minus 3. Okay, so these 2 combine to give me x squared minus 1x minus 2. And here's our third group, x minus 3. Let's go ahead and multiply. I get x cubed minus 1x squared minus 2x, negative 3x squared, positive 3x. You really got to take your time here to make sure you're not making any small mathematical mistakes. The reason I really like this, again, goes back to when you combine like terms, notice that the diagonals already have things organized by like terms. So I have x cubed. Okay, now these 2 are going to give me negative 4x squared. This is going to be positive 1x and positive 6. But I still have 1 left to combine with. So 1, 2, 3, 4. I have 4 terms. 1, 2, 3. There we go. X cubed minus 4x squared plus 1x plus 6, and out front is this singular x. Multiplying to get x to the 4th minus 4x cubed plus 1x squared plus 6x. So I believe that the polynomial equation x to the 4th minus 4x cubed plus 1x squared plus 6x produces 4 solutions, 2, 0, negative 1, and 3. Before we jump into the complicated ones, I want you to write down example number 3, press pause on this video, attempt it, and then come back to the video to see did you correctly find a polynomial equation with these 3 unique solutions. All right, you're back with me. I'm starting with x subtract, x subtract, x subtract every time, and now I'm dropping in the negative 2, and positive 3. 2 negatives make a positive, so I have the parentheses or factors x plus 2, and x minus 3. I'm going to start by combining these two. Now I'm using what looks like these boxes or rectangular ways in order for me to simplify things down to this form. If you prefer simply to distribute, you can do that as well. All right, here we go. X plus 2, x plus 2, x squared plus 2x plus 2x, and plus 4. So combining these two gives me x squared plus 4x plus 4. All right, so I have three things here. I'm going to be lazy. And there's 1, 2, so there's 3. Going down the side is x minus 3, x and minus 3. Multiplying to get x cubed, multiplying to get 4x squared, multiplying to get 4x. Multiplying to get negative 3x squared, multiplying to get negative 12x, and multiplying to get negative 12. Here we go. I have x cubed combined to get positive 1x squared, combined to get negative 8x minus 12. There is a polynomial equation with these three unique roots. Now, if somebody asked you, and we'll learn more about a double root, but if somebody asked you what are the roots, you would simply say negative 2 and positive 3. And we're going to learn what they look like on a graph at a later time. But if you plugged in negative 2, or if you plugged in positive 3 into the right-hand side, it would equal 0 because they are considered to be real solutions to this equation. Let's now move on to the complicated problem. Same concept now, but instead of me just providing you with only integer solutions, we're now going to involve values that are not quite as pretty. So let's get started doing the exact same thing. We're going to have x subtract, and x subtract. In here, I'm going to drop in a negative 3, the square root of 2, and negative square root of 2. Two negatives make a positive. Y equals x plus 3, x minus the square root of 2, and x plus the square root of 2. Now I'm going to start because I want to show you, I'm going to multiply these two first. X and negative square root of 2, and x and positive square root of 2. X times x is x squared. X times negative square root of 2 is negative square root of 2x. Notice the x is outside or in back of the radical. It's not underneath with the 2. X times positive square root of 2. And now positive square root of 2 times negative square root of 2. Well, positive times negative is a negative, and 2 times 2 is 4. But I know the square root of 4 is actually 2. So this becomes negative 2. Now here's the cool part. When you have the exact same value in the front and in the back, the only difference is one is a positive and one is a negative. When you go ahead and multiply those parentheses, it's like multiplying the fronts. Okay, let's see how I have that. But the middle two terms are going to be exactly opposite. One's positive and one's negative. And so they cancel out. They're additive inverses. And then in back, by multiplying negative square root of 2 times positive square root of 2, I get a negative square root of 4, which simplifies to negative 2 because the square root of 4 is 2. So that's what I have from these two terms. Now we're going to take that times this term. So I have two terms when I multiply these two, and I'm going to take it times x and positive 3. I don't want to get confused there. There we go. Okay, x times x squared is x cubed, and I multiply here to get negative 2x, multiply to get positive 3x cubed, squared, and x times negative 2 is negative 6. Now, you may be wondering right now, because that actually just caught me off guard. In this case, you're going to see how the diagonal don't have the exact same terms, and that's because what I did worked, but I should have been showing this example. I should have said to you, it's like when we did synthetic division at the end of last week. Okay, this is x squared, but notice there's no singular x, so I'm going to put a 0x there. I'm going to put a placeholder of a 0x because it doesn't exist in this particular expression. Now, if I went through and I multiplied, I'd have x cubed, x times 0x is 0x squared, x times negative 2 is negative 2x, 3x squared, 0x, and negative 6. And so I have an x cubed combined, remember you're adding them to get 3x squared, combined to get a negative 2x, and lastly is a negative 6. That's my equation. Now I could have achieved that up here as well, but I would have had to be careful because notice that in this diagonal these are not the same terms. I can't combine them. So plus 3x squared minus 2x and minus 6. And notice how I get the exact same thing. So it's probably important for you, unless you're really cognitive of not making that mistake, is if you are missing a term, in this case it was the x to the first term, to put a 0x there when you're using this method. All right, so what does this mean? It means that in order for us to find a solution of 0 for y, we could plug in negative 3 and wherever we see an x, do the math, it would equal 0. We could plug in the square root of 2 or the negative square root of 2 and we still would get an answer of 0. And again, we will learn what that looks like on a graph in this upcoming week. Let's move on. 2 examples left in this video. So here's the first one. And I really want to build upon what I just talked about here. That's really what I want to build upon. Notice that when I drop these down and I'm looking at these parentheses and they're exactly the same, just the signs are different. They're called conjugates. Conjugates. The fronts and the backs are the same, but the sign is different. How are we able to do that? Well, there's a trick. We only have to multiply the fronts and multiply the backs, and that's what we achieve. Well, we're going to see that right now. So I'm going to start with y equals x subtract and x subtract. Now, why did I leave so much space? Because in this space, let's see if this pencil looks a little different. I'm going to drop down what I have. There we go. I'm going to drop down 3 plus the square root of 5 and 3 minus the square root of 5. Just like I did before, but I got to be very careful here. Now I'm going to distribute the subtraction sign to both terms inside. X subtract 3 and subtract the square root of 5. X subtract 3, that's just normal 3. It's ugly, but it's normal 3. Oh, negative times negative is a plus the square root of 5. And my goal here, again, is to come up and create this polynomial equation with these 2 exact solutions. Okay, so how can I go about doing this? I'm going to go ahead and say I have 3 terms here. Let's see what this looks like. I just made a 3 by 3. It doesn't matter if this goes across the top or down the side. There's x, negative 3, and negative square root of 5. X, negative 3, and positive square root of 5. And I'm going to start by distributing x. X squared minus 3x minus the square root of 5. Make sure that x and back. Now I'm going to distribute the negative 3. Negative 3x, positive 9, and positive 3 square roots of 5. I'm going to distribute the square root of 5. Positive square root of 5 with an x, multiplying to give us a negative 3 square roots of 5, and multiplying to get a negative square root of 25. Well, the square root of 25 is really going to be negative 5. That's going to be a negative 5. Now in here, I'm going to have to look around, and we're going to see parts that are going to be additive inverses. So I'm just going to search through this right now. And why is this one a little bit more unique than any of the other box methods that we've used? Because look here, we have an x and we have a value, an x and a value, right? We have an x squared, an x, and a value, and an x and a value. Well, here, these 2 both don't have an x, and yet they have their own box. And these 2 both don't have an x, and they have their own box. So we're going to search through this. There's only one of the 9 terms that is an x squared. So x squared, and I'm going to cross it out. Now I'm going to look for additive inverses. Notice how these are exactly the same, but one's positive, one's negative. Well, those are additive inverses. They cancel out. Exactly here, too. Positive 3 square roots of 5 and negative 3 square roots of 5. They cancel out. And now I have a negative 6x and a positive 4. So if I plug in this value in for x and I do the math, it should equal 0. And if I plug in this value for x and I do the math, it should also equal 0. Let's go on to our final example. I would like you to take a shot on how you can achieve the correct answer here. And then press pause, come back, and let's see if you got it right. So if you are back with me, I'm going to start by setting this up. I'm going to have 3 different parentheses here. X subtract, subtract. These are smaller parentheses, but I can see these 2 need to be much larger. X subtract and x subtract. Now I'm also going to put a bracket inside of here. When I drop this down, it's 3 subtract the square root of 7 and 3 plus the square root of 7. These are going to mimic what we just did in the last example. This is x subtract 0, x subtract negative 1, and x subtract a positive 2. Okay, well, let's see what we can simplify here. X subtract 0 is simply x. 2 negatives make a positive. X subtract 2. Okay, let's see, what do we get here? We have an x subtract 3 subtracts the square root of 7. And x subtract 3, 2 negatives, plus the square root of 7. Now we can go about doing this in any order you like. I think I'm going to do these two first. So this has 3, and this also has 3 terms. And this is going to mimic example number 5 that we just finished. So x minus 3 minus the square root of 7, x minus 3 plus the square root of 7. Okay, I'm going to start by multiplying by x. X squared minus 3x minus the square root of 7x. I'm going to do negative 3 now. Negative 3x, positive 9, and positive 3 square root of 7. And now positive square root of 7. Positive square root of 7x, negative, I think I did that one wrong. Negative 3 square roots of 7, and negative, okay, positive times a negative is a negative, and square root of 7 times the square root of 7 is square root of 49, but I know the square root of 49 is simply 7, so that's a negative 7. Well, let's see what we can cancel out. Look at these two, they're additive inverse, exactly the same thing, different signs, they cancel out. Look at these two, exactly the same sign, exactly the same value, but just different signs, they cancel out. And I'm left with x squared minus 6x plus 2. So that's these two. I'm going to actually go ahead and I've taken care of those two. Now I think I'm going to go ahead, I'm going to combine these two. Those would be pretty easy to combine. They both just have 2 terms. X plus 1 and x minus 2. X squared plus 1x minus 2x minus 2. So I end up with x squared minus 1x minus 2. Okay, these are the back 2 parentheses, the back 2 factors. Again, back 2 factors. These are the second and the third factor. I'm going to go ahead and put those two together. 3 terms and 3 terms. If I can move this up. 3 terms and 3 terms. A common question is, how do I know if this is supposed to go across the top or down the side? It doesn't matter. X squared minus 6x plus 2 and x squared minus 1x minus 2. Here we go. X to the 4th minus 6x squared plus 2x squared. Multiplying now by this negative x, negative 1x cubed, positive 6x squared, and negative 2x. And lastly, negative 2, negative 2x squared, positive 12x, and minus 4. Okay, this is what I have now. What do I do next? Well, let's see what we can do. There's one term that is x to the 4th. And then, this is what I love about these diagonals, negative 7x cubed. Okay, negative 2 and positive 2, hey, they cancel out. And then I'm only left with a positive 6x squared, positive 10x minus 4. So I've done all of this work, and here's the cool thing. Here's the reason why I left this one for last. Because ultimately, all of this is doing is distributing. So when I distribute an x by this, that means I take this entire thing times x. It's really easy to get my final answer in standard form. Y equals x to the 5th, attach another x, attach another x, attach another x, attach another x, and lastly, attach an x. So I believe this is the polynomial equation with these 5 unique roots. Okay, at this time now, please go ahead, and there should be 6 problems at the end of the assignment you were provided on Friday.